Technological advancements offer promising solutions for creating sustainable polymer supply chains. The Internet of Things, blockchain, and integrated sensing and communication are transforming how we produce, track, and manage polymers. These technologies offer unprecedented levels of transparency, efficiency, and environmental responsibility. By embracing these innovations, the polymer industry can pave the way for a future where synthetic materials are produced and used sustainably. This shift towards eco-friendly polymers requires a collaborative effort. Stakeholders across the entire supply chain, from raw material suppliers to manufacturers, distributors, and consumers, must work together. Governments and regulatory bodies play a role in setting standards and incentivizing sustainable practices. By embracing innovation and collaboration, we can create a circular economy for polymers, where resources are used efficiently, waste is minimized, and environmental impact is significantly reduced. The convergence of IoT, blockchain, and ISAC marks a turning point in the journey towards sustainable polymer supply chains. Each technology brings unique capabilities, and their combined power is transforming the industry. Imagine a network of sensors deployed across a polymer manufacturing plant, constantly collecting data on energy consumption, emissions levels, and resource usage. This is the power of IoT in action, enabling real-time environmental monitoring and driving energy efficiency in polymer production. By tracking these critical metrics, manufacturers gain valuable insights into their operational footprint and can identify areas for improvement. Waste reduction is a critical aspect of sustainable polymer supply chains, and IoT technology offers powerful tools to minimize waste generation throughout the production process. By integrating sensors into various stages of manufacturing, companies can track material flows, identify bottlenecks, and optimize production parameters to minimize scrap and reduce overall material waste. The transportation of raw materials, finished products, and waste streams represents a significant portion of the environmental impact associated with polymer supply chains. IoT technology plays a crucial role in optimizing logistics and transportation operations, reducing fuel consumption, minimizing emissions, and promoting more sustainable practices throughout the supply chain. One of the key applications of IoT in logistics is the use of smart sensors to monitor environmental conditions during transportation. Temperature, humidity, and other factors can impact the quality and integrity of polymer materials, particularly during long-distance shipments. Blockchain technology is revolutionizing the way we source raw materials in the polymer industry. By offering an immutable ledger that records every step of the supply chain, blockchain ensures that materials are sourced ethically and sustainably. This transparency is crucial in an industry where the origins of raw materials can often be opaque. For instance, blockchain can track the journey of bio-based polymers from their agricultural origins to their final use in products. In today's market, consumer trust is a valuable commodity. Blockchain technology offers a way to build this trust by providing verifiable proof of a company's sustainability efforts. With blockchain, companies can document each stage of the supply chain, from raw material sourcing to final product delivery, and share this information with consumers. One of the most significant advantages of blockchain is its ability to verify environmental claims. Companies can use blockchain to show consumers the exact environmental impact of their products. For example, a polymer manufacturer can provide data on carbon emissions, water usage, and waste generated, all verified by the blockchain. This level of transparency is increasingly important for eco-conscious consumers. In the realm of polymer supply chains, maintaining the integrity and quality of materials is paramount. This is where integrated sensing and communication, or ISAC, takes center stage, revolutionizing material handling and storage practices to ensure sustainability. ISAC's network of sensors provides real-time insights into environmental conditions, enabling companies to optimize storage environments and minimize material degradation. Consider the sensitivity of certain polymers to temperature and humidity fluctuations. Exposure to extreme conditions can lead to degradation, compromising their properties and rendering them unusable. ISAC sensors, strategically placed within storage facilities, continuously monitor these critical variables. ISAC's ability to provide real-time data extends beyond warehouse walls, transforming the entire polymer supply chain by offering unparalleled visibility and optimization opportunities. With ISAC, companies can track the movement of materials from the point of origin to the final destination, gaining valuable insights into every stage of the journey. Imagine a shipment of specialized polymers making its way from a production facility to a manufacturing plant on the other side of the world. Traditionally, tracking the progress of such shipments involved relying on fragmented information and estimated arrival times. ISAC changes the game by providing real-time location tracking, temperature monitoring, and even security alerts throughout the journey. Section 11. Strengthening collaborative efforts for sustainability. ISAC's transformative impact on polymer supply chains extends beyond individual companies, fostering a collaborative ecosystem where stakeholders can work together towards shared sustainability goals. By enabling seamless data sharing and communication, ISAC breaks down silos and promotes transparency across the entire supply chain. Consider the complexities of managing waste streams in the polymer industry. Traditionally, each stakeholder along the supply chain managed their waste independently, often with limited visibility into the waste management practices of others. ISAC provides a platform for collaboration by enabling the real-time tracking and sharing of waste data. Real-time compliance with environmental standards. The integration of IoT, blockchain, and ISAC creates a powerful synergy that elevates environmental compliance in the polymer industry from a periodic check to a continuous process. This real-time compliance monitoring ensures that sustainable practices are not just aspirations, but are woven into the very fabric of polymer production and distribution. Imagine a scenario where a sensor in a polymer processing plant detects a spike in emissions, exceeding permitted levels. Instead of this violation going unnoticed until a scheduled inspection, the integrated system springs into action. The IoT sensor instantly relays the data to the blockchain, creating an immutable record of the event. The journey towards sustainable polymer supply chains is an ongoing process of innovation and collaboration. IoT, blockchain, and ISAC provide the tools and transparency needed to transform the industry. These technologies enable real-time monitoring, enhanced traceability, and data-driven decision-making. Embracing these advancements, the polymer industry can actively contribute to a more sustainable future. Imagine polymers produced in a closed-loop system, minimizing waste and reducing reliance on finite resources. This vision of a sustainable polymer future is within reach, driven by transformative technologies. Thanks for watching. If you found this video helpful, please give it a like, share it with others, and let us know your thoughts in the comments below. Don't forget to hit the notification bell to stay updated on our latest content.